Let's say we have this little post sticking out of the ground, and there are two forces acting on this post. The first is force A, which is 10 newtons, and the second is force B, which is 15 newtons. The angle that force A makes with the vertical is 40 degrees, and the angle which force B makes with the vertical is 20 degrees. We want to find the resultant force acting on this post and its direction. I'm going to call the resultant force R. Well, we do not know which way the resultant vector is acting, but we do know how the two vectors A and B are configured. We know their magnitude and we know their direction. We can use trigonometry once again to figure out the magnitude of our resultant vector and which way it's acting. Let's use the triangle rule to figure this out. Remember, vector addition is commutative, so you can add vector A plus B or vector B plus A, and you'll still get the same result. To change things up a little bit, I'll go ahead and use the triangle rule and add vector A to vector B. So the first thing I want to do is redraw vector B. We know that this angle here is 20 degrees. Next, we want to add vector A to vector B. I will use the tip-to-tail method and draw the tail of vector A to the tip of vector B. We know that this angle here is 40 degrees. Now, I can draw the resultant vector from the tail of vector B to the tip of vector A. We next need to calculate this angle here, which I will call delta. Delta is simply 180 degrees minus 20 degrees minus 40 degrees, which is equal to 120 degrees. Now, guess what? We can use the law of cosines to calculate the magnitude of vector r. We can write r squared is equal to the square of 10 plus the square of 15 minus 2 times 10 times 15 times the cosine of delta, which is 120 degrees. If we solve this out, we get that r is equal to 21.8 newtons. Finally, we need to calculate which way the resultant vector is acting. We could do this many ways, but I want to take a little look at this point here. If we zoomed into this point, we can draw our x and y coordinate system, and we can draw the vector B and the resultant vector r's line here. Now I want to calculate this angle here, which I will call theta, that goes to the red arrow. It looks like it's slightly less than 90 degrees. In order to calculate this angle, we need to calculate this tiny angle here, which I will call phi. If we use the law of sines on our original triangle, we find that this angle here is 23.4 degrees. If we subtract 20 degrees from 23.4 degrees, we get our angle phi, which is 3.4 degrees. Now we can find our theta angle as 90 degrees minus 3.4 degrees, which is equal to 86.6 degrees. Finally, we can conclude that the resultant vector of forces A and B is 21.8 newtons acting at 86.6 degrees below the horizontal.